Hello, I thought I'd try another video. I just wanted to highlight some things coming up here in the pattern. Obviously, it's going to get colder. Show you a little bit of why, but not a lot why, because I don't have a lot of graphics today. I do have some indexes or indices, whatever you want to call them. They kind of show you those things, but I'm just going to talk about them unless you really study much about weather. You may not know them, and so this may be too geeky or over your head or whatever. It's not because I'm trying to be over your head. It's just because it's not something that would be of interest to you to go that deep or in depth on. So I'll explain it, but you know, take it as you will. The big news is cold is going to come. Is it coming? And it's going to get after it gets cold. Really, the flow is not one that I really see producing much precip. So I'll explain that in one map. It actually is just a quick peek into next week from the European as the cold air gets in here, and I'm just going to draw a few things on there to show you what would happen or how we potentially could get some type of precip, whether it be frozen or not, out of that. I want to start off just by looking at the global sea surface temperatures. The big news in general is that we've had a long enough time period now for for the regions out in the ocean to actually call this a true El Nino. It's really kind of a light to moderate one. It's not really, so I'd say it's like a very neutral positive. It's not a strong one. It's not really moderate yet. If it gets to moderate, we'll have a little more to talk about. I'll explain to you why in just a minute. We continue to have this above normal area up here in the Northeast Pacific. There had been a series of storms coming in like this, which kind of cooled this area, but you can see that it's kind of recovering. So any cooling is stopping. So again, I'll explain a little more why. And again, this is important for our winter. What happens is the NAO tends to be more favored when you have this type of sea surface temperature pattern. When you have this cold pool, warm, and warm, the NAO tends to be negative. You need that block up here to block stuff down the East Coast. So it's an important piece of the equation. You hear Greenland block, negative NAO. That's what it's all about. It's well, not this. This isn't the only thing it's all about, but that's the area that you want to see set up kind of based on historical watching patterns and things that are going on. So what's going on? There's a huge storm out here in the Pacific that's going to come up in this region and it's going to disrupt the weather. I don't know if you've been watching or reading or whatever, but a recurving uh, cyclone, a large cyclone in the western Pacific Ocean, when it recurves and goes like this, it's usually a very strong sign because it disrupts things and starts to pull or push things down here to the U.S. And that is what we're going to see. And this was no storm. I mean, at one point it had 180 mile per hour winds sustained, and that is a powerhouse of a storm. So just to note, what's going on. So what are all these things important for? Well, when you get warm air up here, you tend to get more of a ridging pattern. Warm air, warm sea surface temperatures, warm air. You tend to get a ridging pattern, which makes the jet stream do what I'm saying here, which tips up here, pulls the cold air down. This happened all last winter. Here it is again this winter, or what's about to be winter. Again, I talked about the NAO in depth already. NAO is necessary to block storms from being able to just go out to sea. They tend to get stuck and then come up the East Coast. Important for big East Coast storms. And also to lock in cold air, because here comes this cold air, it comes down, and it gets the brakes put on because it runs into blocking patterns. They're blocking the cold air here in place. So you don't just have a quick cold shot come through and exit, you actually have cold shots that come down and get stuck. So another very important part of why this winter is slowly looking more and more like a serious situation. And then the last thing you have is this El Nino. How much of an influence it is kind of debatable. But what I will tell you is it provides moisture and energy into winds are coming here, and it's called a subtropical jet stream. If you get this to link up with this cold, well, you can guess that helps. And of course, these storms can't just go out to sea; they come to the coast, and you get a lot more chances for a nor'easter that's got the energy and the charge of what's needed for big time weather producers, precip producers, and obviously the more energy and more moisture you get into that, the better. So all those things are kind of coming together. That's part of the whole winter outlook, the whole winter look at these things. So really quick, just to talk about the different things that we can see coming up in the system. See if I can get these in order. So the first thing is Arctic oscillation. Now, Arctic oscillation, Arctic. So we know we're dealing with things that are up in the way northern hemisphere. When they go negative, when there's a negative oscillation, you will tend to get more blocking up there in the poles, and you get pushing down into the cold air towards the United States, or the northern hemisphere is going to be pushed further south. And we see pretty strongly that over the next week we're going to go pretty negative here with the negative oscillation. I mean, this is just obvious. I don't know if I need to draw the obvious. Another thing we're going to see, we talked about this as the NAO. The NAO is that, again, that blocking that's off the northeastern areas of North America over near Greenland. The block does appear to show up here. So, I mean, here we've got blocking going on. So, again, same deal. The NAO needs to go negative in order for that to be a block, and that NAO is going to be negative. NAO negative is always a important sign for bringing coastal storms up the East Coast, also to just block whatever's trying to move along in the jet stream in place. Next thing we're going to look at is what is called the Pacific North American pattern. Pacific makes sense. North American, the piece that interacts. Again, I was mentioning this here on this in this chart here, this picture here. Again, showing this is kind of a P&A pattern where you get a ridge out here. I should say it's more like this. So if you get a ridge or push up here, you're going to pull cold air down here in the east. So we look for P&A patterns. You get the negative NAO, P&A ridge, negative NAO pushing out. We've got all the pieces coming in. The last one is the negative EPO, and that is when we actually link way up here across the, towards the poles, and we get that oscillation, and we look for that thing to go negative, and it doesn't go just negative. I mean, it tanks, and I think this is the big sign here, and a strong negative EPO pattern, Eastern Pacific oscillation. When you get that way up there in the Pacific, this is where we get our linkage to really cold air because it goes up into the Arctic regions. And thus, that is what we're looking at for the long term. That's why people are calling, here comes a cold, this is what's going on. You get that. This is all kind of a buckling or response to, one, the fact that Siberia has been super cold because there's cold air up in these Arctic regions, where if you get a jet stream to go way up, it will actually pull air from across the poles in the Arctic regions into the eastern United States. It will bring it down, and it gets really, really cold. So you get a huge linkage here. I mean, we're talking cross-polar flow. How strong that sets up just a little bit here or there, but that's what looks like it's going on. That's why the second part of November looks like it's going to be cold. And the fact that we're getting blocking in all those regions means that once that stuff comes, it's not going to just go away. It's going to establish itself and get reinforced because it's not going anywhere. We're blocking everywhere. So that's all the pieces that are going on as to why it's going to get colder. So I'm going to bring up a really quick European map. I'm not going to do very long here, but I just wanted to show you again. These are kind of winds and things, the 850 millibar area. I'm just showing you kind of the sense of the general flow. This is towards next week. I mean, actually, it's a little even sharper than that. But, we're getting this cold air. You get a strong ridge, it's bringing it up, and it's pushing this cold air down in this European model. I won't go too many more details here because this is probably just real quick look, but you can see all the winds and things are coming towards the U.S., and these are really, really cold. I mean, this is December to maybe even early January type of cold in some areas. We're going to just see how that lines up. So how in the world do you end up with precip? I mean, because here's what's happening. At this point in time, on any of the maps I've seen, I'm not seeing much of a southern jet or southern hemisphere, the southern jet stream coming in here to bring in moisture. So what is going to actually bring us any chances of precip? It's a good question. And I'll just explain it to you kind of on this map because I don't think it's fair that I'm using the European model is not something that I should be showing too much of. What happens is these fronts, they come through, you get these boundaries set up, the boundary between the cold and the warm air that is there, and that's a front. I mean, that's what a cold front is doing. It's differentiating the cold and warm air, or warm front, the cold and warm air, whether or not the warm air is advancing versus cold air advancing is what's going to happen. So you get this to set up. Right now it looks like it's going to set up maybe North Carolina, Virginia area, and there's this boundary that's hanging out here. And what happens is sometimes energy kind of develops on this, or what we call a wave of low pressure or a disturbance along the actual jet, because there's some type of a buckling or energy that gets introduced somewhere. So you get this little wave of low pressure. You get some spin, you get some moisture influx, and you can get some overrunning situations where maybe you get a chance for some lighter precip, or I mean in some cases you get a bigger one. They're rarely large or serious types of scenarios where you get that. That's honestly what's going to probably have to happen just based on this flow. There's not a lot of southern stream influence, so what you're going to have to get is a piece of energy to kind of dig this system down a little bit as it comes around the jet, and as it digs, and kind of creates something like this, it digs a U in there with the low, you're going to get this push of moisture out in front of it, and that push of moisture is going to override the cold air, and then thus overriding cold air, you could potentially get some snow. That's the only thing I can see happening right now. Honestly, models are not showing that. In the long term, there are a few hints of something kind of like that possible on some of these models, but honestly, nothing's been consistent. There's really nothing there. As a matter of fact, if you look at the Climate Prediction Center's long-range outlook, they're showing below or much below normal precip. Give me one moment, I'll bring that. All right, so what I'm looking at here, this is a 6 to 10 day temperature outlook. I mean, you can see below to a bunch below normal, very, very high risk of very below normal temperatures. That's that Arctic air coming here. Here's the ridging on the west coast, as we mentioned before. Then you can see the precip, though, is below normal. And why? Because, well, when you're coming from landlocked areas up here, you're not going to get, sorry, I'm looking at the wrong one because you can roll over it. You're not going to get a lot of moisture because it's going to all wring out, or, it's coming from dry areas. That's why we're not seeing that potential, and precipitation in the 8 to 14 or the 6 to 10 is pretty much showing below normal in these areas. That's what it looks now. That's what the models are showing. So, I mean, that's kind of the idea. So here's a few of the trends below to much below normal temperatures, some of the risks that are out there. They call these kind of risks or hazards. 8 to 14 day period, it's showing these risks. It's also showing more dryness out in areas that really need rain. That's kind of it. All right, I've talked long enough, so just thought I would share, and hope you enjoyed it. I will turn it back to your regularly scheduled programming of the day. All right.